Hello everyone! For today, we're going to tackle the mean, median, and mode of ungrouped data. First of all, what is measures of central tendency of ungrouped data? When we say about the measures of central tendency of ungrouped data, it is the summary measure that describes a whole set of data with a single quantity that represents its center or middle of its distribution. In other words, it tells us where the center or the middle dataset is located. The most commonly used measures of central tendency are the mean, median, and mode. So, let's tackle first the mean. Mean. The mean of n numbers is the sum of the numbers divided by n. Most commonly used measure of central tendency. Here it is the equation to get the mean. X bar is equals to the summation of x over n. X bar represents as the mean, and summation of x is the sum of all the given data, and n is the numbers of data that we have. For example, Jessie's math teacher said that their final class grade is based on the average of all exam grades. Jessie has gotten a 95, 88, 75, and 97 on her math exams. What is her average? We have a keyword here of average, so that means that we need to find the mean. So to get the mean, we need to use the formula. X bar is equals to the summation of x over n is equals to, write down the given data, 95 plus 88 plus 75 plus 97 divided by 4 because we have a 4 data is equals to 355 over 4. Then calculate and we get the mean of 88.75. So that means that her average, or rather Jessie's average, is 88.75. Another example. A group of customer service surveys were sent out at random. The scores were 90, 50, 70, 80, 70, 60, 20, 30, 80, 90, and 20. So, find the mean score. Again, use the formula of mean. X bar is equals to the summation of x over n. So, just add, write down the data that we have. 90 plus 50 plus 70 plus 80 plus 70 plus 60 plus 20 plus 30 plus 80 plus 90 plus 20 over 11 because we have 11 data is equals to 660 divided by 11. So calculate and we get the mean of 60. So that means the mean score of the customer service survey is 60. Our next measure of central tendency that we're going to tackle is the median. Median. The median of a ranked list of n numbers is the middle number if n is odd. This will be our symbol for our median. So, if our n is odd, we're going to get the middle number and that will be our median. The mean of the two middle numbers if n is even. And if our n is even, we're going to get the mean of our two middle numbers. So, for example, the following data points represent the number of points scored by each player on the Wildcats basketball team last game. 8, 5, 8, 4, 12, 8, 13, 5, 9. Find the median number of points. So, in order to get the median of this data, we need to sort our data from least to greatest or either greatest to least. So for me, I set the data from least to greatest. 4, 5, 5, 8, 8, 8, 9, 12, 13. And here we have an odd numbers of n. So we will just get the middle number, and that will be our median. And here the middle number is 8, so our median will be 8. Another example, what is the median score achieved by a student who recorded the following scores on 10 math quizzes? 68, 55, 70, 62, 71, 58, 81, 82, 63, 73. Again, to get the median, first we need to sort the data from least to greatest or greatest to least. So 55, 58, 62, 63, 68, 70, 71, 73, 81, and 82. Here we have an even number of n, so we will be going to get the mean of the two middle numbers here. So the median is equals to the two middle numbers, which is 68 and 70. So 68 plus 70 divided by 2, and that will be our median, which is 69. Our next measure of central tendency that we're going to tackle is the mode. Mode. The mode of a list of numbers is the number that occurs most frequently. The number or value or observation in a dataset which appears the most number of times. For example, what are the mode of the following numbers? 12, 0, 15, 15, 13, 19, 16, 13, 16, 16, 14, 11. The solution will be arrange the dataset in ascending or descending order. In this case, I arrange the given dataset in an ascending order. 0, 11, 12, 13, 13, 14, 15, 15, 16, 16, 19. In the given data, the number that appeared the most number of times is 16. As you can see, the number 16 is being repeated 3 times. So that's why 16 is our mode. And the data set is said to be unimodal. Unimodal because we only have one mode, which is 16. Another example. A student recorded her scores on weekly math quizzes that were marked out of possible 10 points. Her scores were as follows: 85, 85, 76, 77, 57, 55, 66, 98, 97, 99, 68, 66, 7. Again, arrange the given dataset either in ascending or descending order. The data set has two modes, 6 and 7. As you can see in the given data, 6 and 7 is being repeated more times other than the other numbers. 6 and 7 is being repeated 6 times, so that will they will be our modes in this given data set. The data set is said to be bimodal. Bimodal since we have two modes, 6 and 7. Another example. Find the mode of the following numbers: 3, 13, 6, 8, 10, 5, 7. As you examine the given dataset, we can see that there are no numbers that is being repeated. So, there will be no mode in this given dataset. We can just put that there is no mode since there is no number that is being repeated. So, we also have another measure of central tendency, which is the weighted mean. The weighted mean of the n numbers x sub 1, x sub 2, x sub 3, and so on, x sub n with the respective assigned weights w sub 1, w sub 2, w sub 3, and so on, w sub n is weighted mean is equals to the summation of x multiplied by weight over summation of weight. This will be our formula in order to get the weighted mean, where the summation of x times w is the sum of the products formed by multiplying each number by its assigned weight, and the summation of w is the sum of all the weights. For example, Table 1 shows Mary's full semester course grades. Use the weighted mean formula to find Mary's GPA for the full semester. Course: English, History, Chemistry, Algebra. Grade BADC. Units 4334. As we have here, the A is equals to 4, B is equals to 3, C is equals to 2, D is equals to 5. To get the weighted mean, we will be using the formula that is being given. Weighted mean is equals to the summation of x multiplied by the weight over summation of weight. So, we're going to input the given data in the formula. So, weighted mean is equals to 3 times 4, since we have our x b, which is equals to 3, and its unit will be our weight, which is 4. So 3 times 4 and 4 times 3 plus 5 times 3 plus 2 times 4. 14, because the summation of weight, which is the units of the course, is 14. 4 plus 3 plus 3 plus 14. So compute 3 times 4 plus 4 times 3 plus 5 times 3 plus 2 times 4 is equals to 47 divided by 14, which is 3.36. So we can say that Mary's GPA for the full semester is 3.36. So that's how you find the weighted mean. We have here another measure of central tendency, which is frequency distribution. A frequency distribution, which is a table that lists observed events and the frequency occurrence of each observed event, is often used to organize raw data. We have here a survey of number of computers per household. This will be our raw data, and we'll be making another table based on this raw data, and that will be our frequency distribution. We have here the number of computers x, and the number of household F. You can say that in 5 households they do not have computers, and in 12 households do have one computer each. In 14 households they do have 2 computers each, and 3 households do have 3 computers. 2 households which obtains 4 computers, 3 households with 5 computers each, and 0 households with 6 computers, and there will be 1 household with 7 computers, and with a total of 40 households. So, to get the mean of the data, we have here the formula of x bar, since we're going to get the mean of the data. So, x bar is equals to the summation of f times x over n. So, we're going to multiply f, or the number of households, by x, the number of computers. X will be our weight and f will be our data. So x bar is equals to 0 times 5 and so on. 0 times 5 plus 1 times 12 plus 2 times 4 10 plus 3 times 3 plus 4 times 2 plus 5 times 3 plus 6 times 0 plus 7 times 1 divided by 40, since we have here 40 households. Compute, we have here 79 over 40, and our mean is 1.975. So the mean number of computers per household is 2. So since we rounded off our answer, and that's how you get the mean by using the frequency distribution. I guess that will be all for today. So thank you for listening.